Doing well. Today we're going to be continuing our notes on periodic trends. All right. And we're going to be focused on today electronegativity. Now, for this, you do need to make sure you've got your notes, something to write with, and then you will need a periodic table because we're working with the periodic trend. All right. So let's go ahead and dive on into electronegativity. So first off, for electronegativity, you do need to know what the definition is. And the definition is the tendency of an atom to pull electrons that are bonded closer to itself. And typically what's going to happen is that's actually going to be into their valence shell. All right, so the tendency. Now remember, tendency is essentially how likely. So how likely an atom is to pull in an electron into itself, into specifically its valence shell. Okay. Now, the most electronegative elements are actually going to be very, very small. All right. So what does that mean? Well, that means they're going to be close to the top of the periodic table, right? Because we know that as we move down, we've got more energy levels. And so since we've got more energy levels, it's going to be larger, right? So electronegative elements are actually very, very electronegative elements are actually going to be closer to the top of the periodic table. So on top of that, we also know that we've got our nonmetals. And remember, nonmetals tend to attract electrons, right? So if we're looking at electronegativity, we know that nonmetals are going to have a very high tendency to attract electrons. Specifically, fluorine is going to have the highest electronegativity. Why fluorine and not something like neon or argon? Well, if you think about it, it's the tendency to attract an electron. Well, why are they attracting electrons? They're attracting electrons because they've got that extra spot for electrons to sit. And if we're talking about things like neon or argon, those noble gases, remember they've got a full valence shell. So there is no space for an electron to actually sit. And so because of that, your noble gases are actually going to have the lowest electronegativity. Okay? Essentially, we say they have zero electronegativity. Now, if we're talking about our general nonmetals, remember nonmetals do tend to attract electrons. So fluorine is going to be the highest electronegative element on the periodic table because it is closest to the top. Now, it's also got the most protons in comparison to everything else on that row, which means it's also going to be the strongest because of its high Zeph, right? That effective nuclear charge. Okay, so the most electronegative element is, again, fluorine. And I keep pointing that out because that is very, very important that you know that fluorine is the most electronegative element. All right, if I asked you what was the least electronegative element, well, you would say your noble gases, right? Specifically, down there at the very bottom, we've got OG, number 118 on the periodic table. It would have the absolute least amount of electronegativity. Okay, all right. So again, your vertical trend. If we're talking about electronegativity, our vertical trend is electronegativity is going to decrease as we move down. Okay, as we move down the periodic table, it is going to decrease. Now, if you look, we actually accidentally flipped these trends. So this should actually say the horizontal trend. And this should say the vertical trend. And we'll actually have those fixed on your notes. But for our horizontal trend and our vertical trend, as we're moving down our periodic table, electronegativity is actually going to decrease. Why? Because we're getting further and further and further away from the nucleus. And so the pull from the nucleus is going to be less because it is further away from that valence shell. Okay, so your electronegativity, that tendency to attract an electron, is going to be lower as we move down the periodic table. Now, what about our horizontal trend? Well, our horizontal trend basically says that as I move across the periodic table to the right, so as I move from left to right, my electronegativity is going to increase. Why? Well, as we move from left to right, we're going to be increasing our number of protons. And so since we're increasing our protons, we're increasing our Zeph, that effective nuclear charge. And so a higher Zeph means more electronegativity. Okay, so that's kind of your general trends. So what I want y'all to do is I want y'all to quickly summarize the horizontal and vertical trends. I misspelled vertical. That's nice. But I want y'all to summarize those two trends real quick in your own words. So pause your video, summarize those trends, and then we'll quickly go over what I write for my summary. All right? Okay, so hopefully y'all paused it, but here is kind of my general summary. So essentially I did from left to right, so I drew an arrow. Electronegativity increases due to the increase in protons, which is Zeph, right? And then for my vertical trend, I said from top to bottom, so as we move down, electronegativity decreases due to more energy levels, so it's further from the nucleus, right? So that's kind of the basic summary. You could come up with your own thing. Hopefully y'all did. If your summary, if you're unsure if it really matches up, please reach out and we'll let you know how that goes. All right. So in the grand scheme of things, that is our general trend. So one thing to know, if we're following our general trend, is that as I move away from fluorine, now why do I use fluorine as my basis? Well, I use fluorine because fluorine has the highest electronegativity, right? Well, fluorine actually has an electronegativity of about 4. So 4.0, okay? So here is actually something you can do to know in general, so your general trend, what the electronegativity of different elements is. So as I move away from fluorine, my trend is, as I move left, okay? So if I go from fluorine to oxygen, and then from oxygen to nitrogen, and then from nitrogen to carbon. Each time, your electronegativity is going to decrease by 0.5. So if I wanted to know the electronegativity of oxygen, I would go from fluorine over to oxygen. Fluorine has an electronegativity of 4, which means oxygen has an electronegativity of 3.5 because you subtract that 0.5. Okay? My vertical trend is as I move down away from fluorine. So down away from fluorine, I'm going to decrease by 1. Okay, so it's -1. So if I'm wanting to know the electronegativity of bromine, so I start at fluorine, I move down to chlorine, so I'm down to 3, and then I move down to bromine, I'd be down to 2. So we would say, based off of the trend, that bromine has an electronegativity of about 2. Okay? All right. So now you know kind of the general basic trend of what we do with electronegativity. Now, we do actually have actual numbers for electronegativity. Essentially, you're going to use the trend unless you're given a table that has your electronegativities on it. So my trend right here is, I would say that I start at fluorine, which remember we said fluorine essentially has a electronegativity of 4. And as we move down, it decreases by 1. As you move down again, it decreases by 1. As you move down again, it decreases by 1. So theoretically, we would say iodine has an electronegativity of 1, right? Well, we know that that's not actually the case. If you look down here on your periodic table on this that was actually set up here, you'll see that iodine's electronegativity is actually 2.66, right? So the trend isn't perfect, but it does give us a general idea and it allows us to actually predict the electronegativities, okay? So what is this table? Well, so this is the actual electronegativity scale for each individual element. And this was actually put together by Linus Pauling, who basically went through and actually tested every single individual element and found that there was a scale of 0 to 4, where fluorine is the highest, and then we know that our noble gases are actually the lowest, essentially 0, right? If we're not taking into account our noble gases, then the bottom left corner of our periodic table should actually be our lowest. So francium would actually have the lowest electronegativity. Now, if you notice, this actual table does not go all the way down to there because it didn't need to go all the way down to there. A lot of those elements down at the very bottom are actually man-made, so we don't find them naturally in the world. And so finding their electronegativities was following the trend instead of actually figuring out their actual number. Okay? All right. So if you're given this table, okay, if you're given something like this, you need to actually use the numbers that you're given. Okay? If you're not given the numbers, then you need to know the trend. And remember, the trend is as you move down, you decrease by 1. And as you move left from fluorine, you decrease by 0.5. Okay? So if I wanted to know the electronegativity of phosphorus, phosphorus is down 1 level. Okay, so we would go from 4 down to 3, and then it's to the left 2. So we would go over to sulfur, which would be 2.5, and then we would go over to phosphorus, which would be 2.0. Okay, and so that would be how we do our general electronegativity. Okay, if you wanted to figure out what the electronegativity actually was. Okay, so let's actually look at this, and it says arrange the following elements by increasing electronegativity. Now remember, increasing means you go from small to large. Okay, and I like to point that out because while I know that you probably know that, sometimes it's just easy to get mixed up with your increasing versus decreasing. Okay, so I've got boron, sodium, fluorine, and oxygen. I'm actually going to circle each of those. And since I've got my table, I use the table. So I have boron, sodium, fluorine, and oxygen. Okay, well, I'm arranging them from small to large. So the smallest would be sodium, and then boron, and then oxygen, and then fluorine. So we would go sodium is less than boron, is less than oxygen, is less than fluorine. Okay? Okay, now what I want y'all to do is I want y'all to pause your video, and I actually want you to solve for the electronegativities in increasing order of B and C. Okay, so solve for the electronegativities of B and C in increasing order. All right, and then I'm going to actually go over it with you. All right, so hopefully y'all paused your video. So let's take a look at this. I've got sodium, magnesium, sulfur, and chlorine. So looking at these are actually all on the same row, and we know that as we move towards from left to right, your electronegativity increases, right? So sodium's furthest to the left, then magnesium, then sulfur, then chlorine. All right, so my electronegativity is going to increase moving left to right. Okay, why? Because we've got more protons, more Zeph. The next trend is nitrogen, phosphorus, antimony, bismuth, and arsenic. So looking at those are all in the same column. We know that as we move down the periodic table, our electronegativity is actually going to decrease, right? So if I'm looking for increasing electronegativity, I'm going to be starting at the bottom and moving up towards the top. So my order would be bismuth, antimony, arsenic, phosphorus, and nitrogen. Okay? All right, so I'm going to do one more with y'all. And then after that, I'm going to let y'all do some practice. We'll go over the practice, and then the rest of the practice that's going to be on here will be for y'all to do as just additional work. All right, so which of the following elements is the most electronegative? I'm asked for silicon or chlorine. So looking at silicon and chlorine, silicon is here, and chlorine is here. So I know that just looking at the numbers, that chlorine is going to be the most electronegative. So chlorine, CHLORINE. So chlorine is the most electronegative. Why? So chlorine is the most electronegative because it has more protons. Wow, it has more protons. Which would mean more effective nuclear charge. Effective. I'm apparently struggling spelling things today. So effective nuclear charge, which is again that pull from the nucleus. And we call that Zeph. Okay? So the reason that chlorine has a higher electronegativity is because it has more protons, and it's on that same energy level. And so since it's got more protons and is on the same energy level, it's going to have more effective nuclear charge, so it's going to have more pull from the nucleus. Okay? So I want you to pause your video, go over your electronegativity, do this next problem here. So potassium and cesium, you're going to compare those two and tell me why. All right, so pause your video. All right, so hopefully y'all pause your video. So let's go over this one real quick. So which one would be more electronegative? That would be potassium. Why? Because it has fewer energy levels, which essentially just means that those electrons are going to be closer to the nucleus. That valence shell will be closer to the nucleus. All right, so I'm going to leave the rest of this for y'all to do as practice. There will be a key to it posted on Canvas. But otherwise, that is the end of your electronegativity. Let us know if y'all got any questions. Bye, y'all.